All right, you've seen this before. This is section 5.3, but in this chapter, you've seen this situation before. You have a triangle, but we extended one of the sides. So when I extended one of the sides, I formed what kind of an angle right there? It's on the outside of the triangle, so we call it a what? An exterior angle, right? This is the exterior angle. Let's call it angle 1. Let's call this angle 2. Let's call this one angle 3. Okay? This is an exterior angle. Review a little bit. We said something about angle 1. We said it's equal to something. By the way, what do we call 2 and 3? We give that a name as well. This is an exterior angle because it's outside. Okay, they're interior, but more specifically, they're farther away from this. Remember, we gave a little story about sitting watching TV and all that kind of stuff. What do we say about being further away from something? Say it. Remote interior angles. These are remote. Remote means be far away, right? If you live in a remote area, that means you're far away from civilization. Remote control, you're far away from the TV. You follow me? Okay, so the remote interior angles. Well, what do we say about the exterior angle in relationship to the remote interior angles? We said angle 1 is equal to what? Say it, Blake. Say it. 2 and 3. 2 plus 3, right? Angle 2 plus angle 3. All right? So this angle on the outside is equal to the sum of the exterior angles. What we're talking about today, we're talking about inequalities in a triangle. So if I talk about an inequality, this is actually an equality, right? Something is equal to something else. Well, if I'm talking about an inequality, what does that mean? Instead of something is equal to something, what? It's not equal, okay? So let's talk about some things that are not equal. Watch. If angle 1 equals 2 plus 3, if you have to add those two things together to become angle 1, tell me something about angle 1 in comparison or in relationship to angle 2 or angle 3. That's right. It's got to be bigger, right? So if I have two things right here, if I have two things, and they add up to be this answer, right? Like, for instance, 2 plus 3. Well, let's use different numbers than that. Let's say 5 plus 4. Okay, 5 plus 4 is what? Is 9. Tell me something about 9. 9's got to be what? Bigger than 5 and what? Bigger than 4. That works for any number that you try. Well, I should say any positive numbers, okay? So any positive numbers, it works for both of them. You with me on that? So if I take two numbers, add them together, like I did right here, and I got this answer has to be bigger than either one of these two numbers, right? Because these two numbers had to be smaller than this one itself. Make sense? All right, so angle 1 has to be greater than angle 2. Do you remember the greater than symbol? Yeah, looks like that. Some teachers use alligator and all that kind of stuff, but just remember what it is. That was pretty ugly. All right, so there we go. I'll just make it a little bit thicker. I'm making it worse, so I'll just stop right there, okay? So angle 1 is greater than angle 2. Well, angle 1 is also greater than what else? Angle 3, that's right. So angle 1 is greater than angle 3. I'm making these greater than symbols just a little bit bigger because sometimes they get mixed up with the angle symbol. Sometimes that kind of looks the same if you're not real careful. All right, so angle 1's got to be greater than angle 2, and angle 1's got to be greater than angle 3. I could write it the other way, couldn't I? I could say angle 2 is what to angle 1? Is less than. That's right. So angle 2 would be less than angle 1. Would you agree? And what else could you say? Angle 3 is less than angle 1. So you're going to have some problems on this worksheet that say, they're going to give you a situation like this, and they're going to say, name all the angles that are less than angle 1. So what do you look for? You look to, what if I put a 4 right there? You look to see the remote interior angles, okay? So angle 1, that exterior angle, is going to be less than both of those remote interior angles. You hear what I'm saying? Because my last class I was saying all this stuff, and I thought I was being very clear, okay? Very deliberate about what I'm saying. But then kids got the worksheet and they're like, how do I know that that's bigger than this and this? Well, I spent all this time up here trying to explain why. All right, so the exterior angle is equal to the sum of the remote interior angles, which means the exterior angle is going to be bigger than the remote interior angle and bigger than this remote interior angle. Make sense? Or you could look at it the other way around. The remote interior angle is going to be what to the exterior? Less than. So this is going to be less than 1, and this is going to be less than 1. Can I say anything about 1 and 4 just by looking at the picture? Not really. Okay, because you're looking at it, you're like, well, yeah, sure. Angle 4 looks obtuse, so that means this is acute, so 4 has got to be bigger than 1. But you can't always tell that, because what if my picture looked like this? And it was like that. Okay? And that was, let's see, we had it like this. But can you really tell, though? I mean, you might be able to tell that a little bit, but you're not really sure, are you? All right, so if I said this is angle 1 and this is angle 4, could you tell just by looking that 1's bigger than 4, 4 is bigger than 1? No, you can't. So you can't go just by what it looks like on the paper. You have to go by the theorems and the things that we've been teaching you. So if this was angle 2 and this was angle 3, I don't know that angle 1 is less than angle 4, do I? Or greater than angle 4. Either one. I don't know. I can't say it is, because I don't know definitively if it is or not. But I can definitely say, without measuring these at all, I can definitely say that angle 1 is bigger than 2, and I can definitely say angle 1 is bigger than 3. Everybody got it? Okay. Let's go on to another type. All right, here's an example for you. I got this from the book. It's on page 346 if you want to see for yourself. First question says, name all the angles that are greater than angle 2. Okay, look at angle 2 right here. Well, what am I looking for when I look at angle 2? I'm looking to see if it's a exterior angle, if it's a interior angle, if it's a remote interior angle, or something like that. Okay? Yeah. What's greater than angle 4? Well, look where angle 2 is. Angle 2 is in this triangle right here. You gotta watch to follow along. Okay? If you're looking somewhere else, Connor, you're not gonna understand what I'm doing. All right. So if I have this triangle right here, this is an angle. Do I have an exterior angle to this triangle? What would the exterior angle be to this triangle right here? It'd be angle 4, wouldn't it? Everybody see that? Say angle 4 is the exterior angle. Say I took this triangle, extended it out. This is an exterior angle to this triangle right here. Got it? So which ones are the remote interior angles? 1 and 2. So tell me something about 1, 2, and 4. 1's got to be what? It's got to be smaller than 4, and what else? 2 has to be smaller than 4. So that means 4 has to be bigger than what? 1 and 2. Or now this problem says, what angle has to be greater than angle 2? That's what the question says. What angle has to be greater than angle 2? Angle 4 does, doesn't it? Okay, not just because it looks like it. You don't come over here and say, well, 5 has to be bigger than that because it's obtuse and this is acute. No, you don't go by that. You can't look at this and say, well, I don't know, 7 looks like it's bigger than angle 2. No, you can't go by what it looks like. You have to go by the information. What's the information? The information is angle 4 is an exterior angle, so 1 and 2, both, right, individually, they both have to be less than angle 4. 1's got to be less than 4, 2's got to be less than 4, which means 4's got to be bigger than what? 2, and 4's got to be bigger than 1. Make sense? All right, so that's the kind of stuff that you want to look for. Look at angle 9. What has to be less than angle 9? Okay, 6 and 7, very good, because that's an exterior angle to this triangle right here. Do you see this triangle? That's an exterior angle, so 9 has to be bigger than 6, and 9 has to be bigger than 7. Or I could ask it another way. I could say, what angle is bigger than angle 6? Okay, 9, right. You can't say angle 8. Angle 9 would be bigger than 6. What if I said, what angle is bigger than angle 7? 5. You could say 5, absolutely. Or you could say 9, too, couldn't you? Watch. Watch. If I said angle 7, I'm looking at this angle right here. What angle must be bigger than angle 7? Well, look at angle 9. 9's an exterior angle, isn't it? Okay, these are the two angles that are furthest away from 9. The ones that are further away have to be smaller than angle 9. So 6 has to be smaller than 9. 7 has to be smaller than 9. You got it? So 9 has to be what? Bigger than 7, and 9 has to be bigger than 6. Okay? What else is bigger than 7, though? Brett, you said it. 5. Why angle 5? This is an exterior angle also, isn't it? Look at this triangle. I took this side and extended this side, didn't I? So look at this angle right here. Everybody see that? So that angle right there is an exterior angle. Which ones are the remote interior angles to that angle? 7 and 8. So 5 has to be bigger than 7, and 5 has to be bigger than 8. Does that make sense? All right. That's the kind of stuff that you're going to do. It's not given just one triangle. Everybody paying attention? Got a lot of people looking away. Look up here. I know I'm not the best thing to look at, but look up here. At least look at the screen. All right. Blake. So 5 has to be bigger than 7. 5 has to be bigger than 8. 7 has to be smaller than 5. 8 has to be smaller than 5. Got it? Look, 6 has to be smaller than 9. 7 has to be smaller than 9. You getting it? 2 has to, let's see this. Look at angle 4. 1 has to be smaller than 4, and what else? 2 has to be smaller than 4. Getting the idea? Look at angle 9. Angle 9 is an exterior angle also to this big triangle right here. Isn't it? So what are the exterior angles, or what are the remote interior angles to angle 9? Angle 1, and what else? Well, not 3. It's that combination of 3 and 6. Okay, it's not really one number angle, but that combination of 3 and 6. Follow me? So if these two add up to be one angle, look, 9's got to be bigger than 3, 9's got to be bigger than 6, 9's got to be bigger than 1. We good with that? All right, we'll see. I'm hoping we covered everything. I think that should help you out a little bit more than what the other class did. All right, let's do another thing. This is pretty easy stuff, I think. Let's make a triangle, and I'm going to make... I don't usually make obtuse triangles. I don't know why. They just seem kind of weird. No offense if you're a big obtuse triangle fan, but they are kind of weird, aren't they? So there you go. Now watch what I'm going to tell you right here. I'm going to tell you, well, let's label it first. Let's call this ABC. I'm going to tell you that angle C is the largest angle of that triangle. All right? That's supposed to be an angle symbol. There you go. Angle C is the largest angle. So I'm going to put a big old arc on angle C. Now we have a theorem that says this. We have a theorem that says if you have the largest angle, I'll tell you what, and we'll make this one the smallest angle. Is that all right? So the side, listen to the theorem, the side opposite the largest angle is going to be the largest side. So if angle C is the largest angle, which one's the largest side? AB. Okay? And it's not just because we looked at it and we measured it with a ruler or anything else. Okay? We have a theorem that says if I have the largest angle of a triangle, the side that's opposite, do you see how that's opposite? The side that's opposite that angle is going to be the largest side. So if I ask you, this is what they're going to do on the homework. They're going to ask you to list from smallest to largest. Okay? The sides. So let's list the sides, the smallest to the largest. I already told you that C was the largest side and B was the smallest side. Okay? So which one is the, I'm sorry, not side, but what? Angle. I misspoke. Angle C is the largest angle and angle B is the largest, or the smallest angle. I want to find the largest, or the smallest to the largest side. Okay? In order, from the smallest to the largest. So how many answers am I going to have? 3, right, because there's 3 sides. So which one's the smallest side then? AC. Not just because it looks like it, but because what? It's opposite the what? The smallest angle. Do you see that? That's the smallest angle, so this has to be the smallest side. It's not always going to look so, I don't know what the word is, so plain. Okay, I mean, this is pretty plain. I mean, that definitely looks like the smallest side, doesn't it? It's not always going to look like that. And sometimes they're going to draw them so they're not drawn to scale. All right? Like, either stand up or you go to the office and you can sleep in there. What do you want to do? All right. Just lean back against there. Stand up. Keep your eyes open. There's no need for that, okay? You can force yourself. At least try to shake it off or something. Okay? You're not showing any signs of your wanting to try to stay awake. So here we go. Watch. Angle C is the largest angle. So what's this? Let's go small to large. I'm sorry. This is the smallest. So what is it? AC. I can go over, it's fine. AC is the smallest side. What's the next smallest one? CB, that's right, because if that's the biggest one and that's the smallest one, this is the middle one, isn't it? All right, so this must be the middle side right there, so CB. Oops, not D. Right, that's a B. All right, I know, I can go over. So watch, thanks anyway. That's the smallest side. CB is the next largest one, that's the one in the middle, and of course, there's only one more left. What would that be? AB. And you know that's the largest one because it's opposite what? The largest angle. Does that make sense? Okay. Look, it works the other way too. Let's get rid of some junk here. Let's get rid of all that. Let's get rid of that. Let's get rid of that. What if I told you that AB was the largest side? I know. This is the third time now. I can go over 15 minutes, all right? Something happened on YouTube where they said I can go over, so I can go like as long as I want now, all right? But I appreciate the warnings. Okay. So watch. Now I'm telling you, I don't know that C is the largest angle right now, but I do know this. Let's do this. Watch. I know that AB is the largest side. I was told that. Somebody told me that AB was the largest side. All right? If I want to put, I'll put like a big old heavy tick mark on there. That's the largest side. Okay, and let's say somebody also told me that AC was the smallest side. All right, so I'll put a little tiny tick mark just to show that that's the smallest. You won't see that in the book, but I just made that up, okay? So this is a big tick mark, this is a little tiny tick mark, so this side's bigger than this. You got it? Okay. So let's put in order from smallest to largest. Let's put the angles this time in order. All right, so what's the smallest angle on this triangle now?
B.
Angle B, that's right, because angle B is opposite AC. So angle B, then what's the next one? Angle A, because look, that's the middle one, right? If that's the largest, that's the smallest. This is the middle one, so angle A has to be the middle one. And then what's the largest one? This is the largest side, so this has to be the largest angle. And there you go. That's in order from smallest to largest. Okay? I think in all the problems they ask you, they always ask you to go from small to large. I don't think they ever ask you to go from the largest to the smallest, but just be aware of that. Just pay attention to the problem and make sure you go in the correct order. And it has to be in this order. You can't just put those three angles there and just expect me to get it right or to give it to you if they're not in the correct order. B has to be first, A has to be second, C has to be third. Does that make sense? That's a pretty easy theorem, isn't it? Yeah, I think it is. Okay, the largest angle is opposite the largest side. The smallest angle is opposite the smallest side. We good? All right, let's do another example with that, and then I'll let you work on some of the problems from this worksheet. Let's find a good example. I'll just do this. Now again, I said some of this stuff may not be drawn to scale, so you got to be aware of that. All right, because I know for a fact some of you guys are just going to look at the sides and say, well, that one looks bigger than that one. That doesn't mean you're right, because you got to go by the numbers. All right, make sure that you do that. So let's say, I don't know, let's say that's 51 degrees. And let's say this is 71 degrees. We'll call this ABC again. And I'm asking you to put in order from smallest to largest, from small to large, okay? The sides, put the sides in order from smallest to largest. And this is the information they give you. That's it. So what are you going to do first? Yeah, figure out what this is. So add those up. What's that? 122. Take that away from 180. Okay, what's that? 58. So this angle right here is 58 degrees. So you really need to find all three angles to find out which one really is the smallest, which one really is the largest. We good? All right, so now We're going smallest to largest. Which one's the smallest angle out of these three? 51. So which one is the smallest side? BC. So BC, put a line segment over top of it, that's the smallest side, BC. What's the next one in order? 58 is in orders, right? Is the next one in order. It goes 51, 58, then 71. So you look at the side opposite 58, which is what? AB. So AB would be next. It's pretty easy stuff, isn't it? And then what's the next one? 71 is the biggest angle, so AC. Of course, that's the only one left, right? So that's got to be the other side. So it has to be in that order. All right? Make sense? Can't just have BC, AB, AC just floating all over the place and I don't know what in order. I got to be able to look at this and see definitely that this is the first one, that's the second one, that's the third one. All right? And that would be your answer right there. We good? All right. I think that covers it. There is a problem on there where it says compare the relationships or something like that. And what they're going to do is they're going to give you they're going to say compare AB to AC. Everybody watching this? You're going to have some problems on the worksheet that says something like this. They do this with angles also, angles and sides. They compare AB to AC. Well, look at AB. AB is opposite 58, right? AC is opposite what? 71. So what is AB compared to AC? What's the relationship? Are they equal? Is one smaller? Is one bigger? What is it? AB is smaller, right? Because AB is opposite 58 degrees. AC is opposite 71 degrees. Okay, the one opposite 58 is going to be smaller than the one opposite 71. So AB is what? Less than. Do you remember those symbols? Okay, AB is less than AC, and that would be your answer right there. So when they say compare the relationships, look at I forget exactly how they word it. You'll see it when you get it. It says something about, you know, relationships between the sides are given, compare them or something like that. That's exactly what they want you to do. They want you to say whether this one is less than, whether it's greater than, or it could be equal to. But I'll give you a big hint. On none of these they're equal, okay? They're either less than or greater than. All right? Hope you're paying attention. A lot of playing around today. Not a good way to start off the new year, is it? Okay. All right, let me give you the worksheet. It's section 5.3, and that's going to be due tomorrow.